everyone, and welcome to Introductory Statistics for the Behavioral Sciences. And welcome to our first lesson, which is just Introduction to Statistics. We're going to get our feet wet and get familiar with some basic concepts and some things that you can expect throughout this course as you learn content and such. Before we get into that, I just want to say that I love statistics. It's one of my favorite courses to teach. I feel very blessed that I get to record these videos for our online course. And so if I don't get the pleasure of meeting you in one of my classes in person, at least maybe we get to have some sort of interaction through these videos, though they are recorded. So let's get into some beginning concepts of statistics. I want to start with this question here, which is, why is learning statistics important? And I find that that's an important question to bring up at the very beginning, because you're thinking, why, I'm taking the classes, I have to, right? And that's understandable. Most students don't want to do math, don't want to do stats, and have to take this because it's required. But let me try to make a case for why learning stats, even if you're not really interested in it, is important for you and can benefit you, especially if you're going to stay in the field of psychology or in some other field of behavioral science. So one is that stats makes you a better student of the behavioral sciences. Primarily because the second point, it makes you a better consumer of research. When you're going into a field of behavioral science, it's a key word, science. It is a field that's built on studying phenomenon, gathering evidence, drawing conclusions. And one of the primary methods that behavioral sciences use to draw conclusions is using statistics to represent and analyze information that we gather as we're studying people and other things in our fields. So you may not actually conduct research. That may not be your goal. Your goal may be to just go into the field and be a practitioner, whether it be a nurse or a mental health professional or things like that. But you should be consuming research. That way you can make sure that what you're doing is evidence-based and that it is accurate, and you're not just doing what has always been done. And so you need to read research. And one of the things about research is you need to understand how the research works. Understanding stats is a crucial step to that point. There's many other things that I could say, but I'd say that these are the two most important things for the average student to take away from statistics. Now, here's the thing I want to start this whole course by prefacing, is that for most of the assignments in this course, you are not going to be doing math by hand done calculations. You're going to be using a statistical software to do a lot of these calculations for you. Okay, so you're going to be using a software called SPSS. I know it's on the slide, but elsewhere on Blackboard it lists information about that, and it's going to do some simple, some complex calculations of statistics for you, so that way we don't have to waste time with getting accurate at calculation. That way you don't have to worry about making a minor mistake because you forgot to carry the one or something like that, right? Don't want to knock you for a slight miss-up in a calculation. The focus of this course is not precision in calculation, but in precision and comprehension. You should understand these concepts even if you're not the best at carrying them out by hand, because we have technology to help us do that. So one of the benefits you can have is that there is no math in this course that you have to do by hand. There may be a little bit on some of the exams or on the quizzes, but it'll be very light, basic algebra 2 type of stuff, things that you'll easily be able to do, and some things I'll give you practice with during these slides. So here's the bottom line for this course. If you participate in the course and you complete all assignments and do well on them, if you study and practice on your own and with classmates, then you will understand statistics and you will pass this course, and may pass with a grade higher than you were hoping to get. I've seen students come in thinking that, hey, I just want a C, just the bare minimum. And they end up at the end with an A, because they were the kind of student that put in the work, they really tried, and they actually started to somewhat enjoy stats, not because they love the numbers like I do, but because they liked understanding something that was a little hard at first, but they got the hang of it. And that's one of the best ways to learn, is when you feel confident that you actually are learning, especially something you never thought you would learn, right? So with all that said, let's get into some basic concepts of what are statistics. And as you can see, this woman here may represent what a lot of y'all think when it comes to statistics. She's wondering about geometry, though, if you're wondering what those math symbols are. So she's thinking of the wrong field. We're talking about statistics, so let's get into some preliminary things. So what are statistics? Well, we got to start at the bottom. Okay, we got to start with the most basic element of statistics, which is something called data. Data is a record of an observation or an event, such as a test score, a grade in a math class, or a response time, like how fast you pressed a key or how fast you did some task. So data, in essence, is information. I want to focus on that for you. Information to be analyzed. And so when you get a bunch of information or a bunch of data together, that's called a data set. It's a collection of data. It's a collection of records of observations, a collection of information. A very common kind of data set you might come across, especially if you're a person who may be going into the medical field or another field that collects kind of biostatistical data on humans, you might come across spreadsheets, as they're called, such as this, where you'll get a bunch of demographic information, such as a person's age, right? Each row is a person, and so this is the column of ages. So first person age is 30, second person 31, so on and so forth. Jump to marital status, right? Are they married? Are they single? Are they divorced? Are they cohabitating? What's their education? Primary education, secondary education, further education than that. You look at other things like, so this picture doesn't have it, but maybe you have to take pulse, blood pressure, height, weight, things like common biostatistical information. So that's all data. And this is all the basic things for statistics. An analogy I want to give you at this point is I want you to think of data as like the building materials for a house, right? What are the basic things you need to build a house? Before you even get to the tools and get to the building, you got to have, well, you got to have the wood, right? To make the frame. You got to have the metal for the piping and for furnishings and for the screws and nuts and bolts and all of that. You need electrical wiring, you need, and the list goes on, right? So I want you to think of data as the resources, the building blocks, the building materials needed to build what will be our statistical analyses, okay? So then what are statistics specifically? We talk about data, right? They're the building materials. If the data is the building materials and the statistics are the tools and techniques, okay, that are used to work with the building materials. Right? How is it that I work with all this information? How do I describe it? How do I organize it, interpret it, right? How do I work with this data? That's what statistics are. So throughout this course, what the goal is for you is that you gain an understanding of all the major tools that are used in statistics that you can then put in your toolbox, quote unquote, to use to then build whatever things that you'll be building, or maybe at least to read the blueprints that you're coming across. You may not actually conduct research. You may not be building any houses in the research field, so to speak. But you may have to just read some blueprints, right? You may have to just be familiar with how the house was built, even if you're not the one who built it. And understanding these tools, at least having these tools around and knowing what they're for, is going to help you accomplish those tasks. Okay, so I'm going to be bringing up this analogy, this illustration frequently, and hopefully it will be helpful to you. I found that it's very helpful for students I've used it with in the past. Now, this set of tools of statistics that you're going to learn fall into two broad categories. The first are descriptive stats, and the second is inferential stats. So let's take one at a time. So let's talk about descriptive stats. The tools I want you to have in mind here are your measuring tools. Think your ruler, think your tape measure, think your square and your level and things like that. The tools that are helping define and describe the building materials you're working with, okay? So just like we use a ruler to measure how long a piece of wood is, we can use certain descriptive statistics to tell us what our data is like. One thing you're going to learn in the next lesson is measures of central tendency, like an average. Calculating an average, that's a form of descriptive statistic. The average is a very common ruler, so to speak, in statistics, okay? Now, what this does is it provides very basic information and understanding of what the data represents. It's just kind of describing us what are the tendencies, the trends that we see in the data. It's not actually helping us draw conclusions just yet. That's what we use the second category for. So inferential statistics are used to make inferences from a smaller group of data to a possible larger one. So my toolbox example doesn't really work for inferential statistics. A better example I like to use is a cake analogy. Say that you go to your favorite grocery store, and sometimes they have the people out in the aisle with a certain product, food product, and they're going to give you a little sample, right? Because they're trying to sell the product. So let's say that they're selling you a cake, they give you a little slice of the cake. So the basic logic underlying that marketing technique is that if you try a piece of the cake and you like it, you will then kind of apply your conclusions about the little sample to the rest of the cake and say, well, hey, if this little sample of cake was great, the rest of the cake must be great as well, so maybe I'll go buy it. Now that logic there, if you've got that, that is the basic logic of inferential statistics. We rarely can study whole populations of people. If I want to study every United States citizen currently residing in the continental 50 United States who are alive and able to participate. That's a lot of people. I can't possibly do that in a reasonable amount of time with the kind of resources that I have. So what we often want to do is take a smaller group of people, which is called a sample, which is a smaller group from the larger group. And so if I find out some things about the sample, then maybe I can apply those observations to the population. I can draw conclusions about the population based on what I conclude about the sample. And that is essentially what inferential statistics are all about. So unlike descriptive statistics, inferential statistics, they can reveal information and help us make possible conclusions that are more reliable and specific than just descriptive stats. So now going back to my tool example, the rulers just describe the piece of wood, how long it is, how heavy it is, right? Where I perhaps need to cut it and things like that. But the inferential stats are what I use to actually work with the materials to begin building the house, right? I use my hammer to put the pieces of wood together, use my saw to cut them to the right size, use my wrench to put the pipes in the right place, and so on and so forth, this analogy goes. So the inferential stats are the tools that you're actually using to work with the materials, doing more than just describing their features. So here's a quick slide to just kind of summarize everything that I just said. This would be a good one to go back and study with on your own. So now I want to give you a little overview of the progression of this course. So if we got those basics out of the way, here's kind of what you can look forward to across the next 8 weeks. So our first section is going to be just summarizing and describing data. This is the section of understanding data. That's going to be your next lesson for this week. Then after that, we're going to get into understanding distributions of data. And that's where we're going to look at things called normal distributions and standardization. Then we're going to look at inference in data. This is when we're going to be transitioning from descriptive statistics to inferential statistics. We're going to cover some basic things like probability and inference, hypothesis testing, statistical significance. And those 3 things there are going to be very foundational for the rest of the class. Once we get to section 4, understanding categorical data, the rest of the class is going to focus on inferential stats. So we're going to start with understanding categorical data, which involves learning about a chi-square. Understanding mean differences in data looks at t-tests and analysis of variance. And then finally, we'll wrap up the class with understanding relationships in data. And the last 2 stats you'll learn are called correlation and linear regression. So just to reiterate, the first 3 topics are looking at descriptive stats, but most of this class is going to focus on inferential stats because, I think when you're building a house, you don't want to just measure all the materials, you want to get the house built. So inferential stats really make up the core of statistics we use in behavioral science. So that's why most of this course is going to focus on learning what those are and how they work, okay? So our last section I want to cover in this video is talking about types of data, and then we'll wrap this up, and then you can look at the summarized and describing data video after this. So not all data is the same. Not all kinds of information are the same, right? There are 2 broad categories of data. The first is called categorical data here. This is data that's organized into categories or groups. Some examples of this would be biological sex, right? You have male, female, or such as candy bars. Let's say that I were to take a poll in the class and rate what your favorite candy bars are. Snickers, Milky Way, Reese's, Kit Kat, Twix. And I were to just, say how many people like Snickers, write it down. Say there were 5. How many people like Reese's? Say there were 7, right? And write that down. Now, these groups are not in any particular order. They're not ranging from least to greatest, right? There's not like male to female, right? From least to greatest. It's not like Snickers to Twix in some kind of ranked order. These are just separate categories of data. Now, data that is on some type of spectrum or that is on some type of continuum is called continuous data. So this is data that's organized along some sort of continuum or scale. Some examples of this would be height and weight that we measure in feet and inches. or pounds in terms of weight, right? So like here for females, you see that their heights tend to range from 4'10" to 6 foot. And then for males on average, it goes from 5'1" to 6'3". And so you got 5'1", 5'2", 5'3", 5'4", all increasing, right? It's a scale, one coming after the next. One is greater than the next, and so on until you get to the end. Another example would be the amount of rainfall that has fallen. Maybe you've seen a rain gauge in backyards or in somebody's house where they're just sitting out there. They measure how much rain has fallen the last time it rained, right? It measures it in inches, right? So do we have 2 inches of rain, 3 inches of rain, and so on and so forth. Houston, 10 inches of rain. Sometimes we know how that can be. Our rain gauges might be a lot larger in Houston than anywhere else in the country. So these are some examples of continuous data. Now, we have to record this data, right? We have to make an observation, and we have to find a way of recording what we're observing, whether it's categorical or continuous kind of data. So now this leads us into what's called types of scales, a certain scale that's used to measure or collect data, okay? So the first scale, called a nominal scale, this is used to measure categorical data. And what it does is it simply labels data. The key word here in nominal is name. So think label data as naming the data, okay? Some examples of this, again, would be biological sex or candy bars, right? I'm not ranking them. There's no order to them. There's just the separate categories with the label. Male, female for biological sex. Snickers, Milky Way, Reese's, and so on for candy bars. I'm just labeling, just naming those categories. Those categories, the categories of categorical data. I know that sounds a little repetitive. Now, ordinal scale, this is very much like a nominal scale, except in this case, the categories have an order to them. So usually some type of rank order. So an example of this is places in a race, right? Yeah, first place, second place, and third place, right? First place comes before second place becomes before third place, and so on it will go. So again, we're just labeling the categories, but now the categories have an order to them. Now, one of the drawbacks of the ordinal scales is that if you want to know how far apart the rank orders are, it doesn't really tell you, right? If you look at the order of people in a race, like people that are standing on the podium in this picture, you know, the guy who won in first place, guy who's in second place, but you don't know how far behind second place was from first place. Was he right on his heels, or was he quite a ways back? We don't know. We just know that he came after first place. That's why he's in second. So if I want to know the actual distance between my orders on my scale, then I need to move into continuous data using the first kind of scale called an interval scale. Now, this measures data along a continuum, such as a scale of 1 to 10. You're probably very familiar with that, taking some kind of survey or quiz, you know, how much do you agree with this statement on a scale of 1 to 10? So we know that 1 to 2 is the same distance as 3 to 5. 1 to 3 is the same as 5 to 7, like I give here on the screen here. It's the same distance, right? 1 to 3 is not a larger distance from 5 to 7. They're each 2 points apart, so to speak. Another example I like to use is temperature, right? The distance from 10 degrees to 20 degrees is the same distance as 20 to 30 degrees. And the same distance from 80 to 90 degrees. It's 10-degree differences, right? 1 degree to 2 degree is a 1 degree difference. 2 to 3 degrees is a 1 degree difference. So the thing about an interval scale is that it's now we're having data on a continuum where each point on the continuum is equally distant from the point next to it. Right? All the numbers are equally distant from each other. Now, the thing about an interval scale is that it has something called a no true zero, meaning that 0 does not actually mean the absence of something you're measuring. So take the thermometer. Does 0 degrees mean no temperature? No. It means really, really cold, right? 0 degrees means really cold. It doesn't mean there's no temperature. It doesn't mean like, oh, there's no cold or hot anymore. It's 0 degrees, which means there's nothing. No, that's not what it means at all. So what happens if you're working with data where the 0 actually does mean nothing? It actually does mean the absence of what you're measuring. Then you would have to use the fourth and final scale. This is the second scale used for continuous data. This is called a ratio scale. Essentially, a ratio scale is an interval scale, has all the same qualities. It's just that a ratio scale has a true 0, meaning that 0 really does mean nothing. So an example of this would be age, right? 0 years old means you're not born yet, right? There is no negative age. There is you're born and then 1 year old, 2 years old, 3 years old is usually how we mark age. So age would have to be measured with a ratio scale. There's no 0 age or below. Another one is income. Now, put aside the fact that you can have negative numbers in your bank account. Let's actually talk about actual money, like money in your wallet, for instance, right? If I were to ask you how much money is in your wallet or wherever you carry if you carry cash, or how much cash is in there. If you have $0, that means you have no hard cash with you at that moment, right? There is no such thing as negative $2 where that's something you can pull out and say like, yeah, here, I'm going to pay with negative $2, right? So income has a true zero in the sense that $0 means no money, okay? And that's essentially what a ratio scale is. So a good review is this slide here. Think of data as falling into two categories. You have categorical data, which is in just different groups, all separate from each other, or you have continuous data that falls on a scale, usually ranging from one value to another. Now, how do I measure categorical data? Well, I can measure it using nominal scale, just labeling the groups, or I can use a nominal scale with an ordinal scale where I have some kind of ranking to the groups. Now, if I have continuous data, I can measure it just using an interval scale from usually a range of one number to another number, where every number on the scale is equally distant from every other number. Now, if the data requires that 0 actually mean nothing, then I'll use a ratio scale, which is an interval scale with a true 0.